Hello grade 9s, and this is the lesson from Thursday the 3rd of September. We're looking at volume, so particularly for those that jumped out halfway and had the usual Wi-Fi issues and load shedding and all that fun, right? So here we go, we got, there was feedback, yes, you got a video. Okay, so we saw this idea of volume and asking what is volume, and it's saying how much space something. I think where we got to was how much space something takes up. So whether that's capacity and liters, maybe weight, something like that, but how much, and the fact that volume's kind of a 3D entity and area's just a 2D entity. So we then want to work out, okay, so the volume of a rectangular prism. But before that, we'd use this word prism and then gone, so what makes something a prism? And what makes something a prism, this is a loose-ish definition, but the general idea is, in our pictures here, if you've got some sort of shape, so let me draw another prism up here. So if you've got some sort of shape and then it's just kind of repeated on the other side, so we've got that triangle, we've got the exact same triangle, and then we just join those together, and this one here is going to be in the background, we can't see it, so there's a triangular prism. We could also have our triangular prism, that's looking at it like it's along like that. Maybe the triangular prism, you've got a triangle like that, and then you've got a triangle, didn't leave enough space there, like that, and then it was joined, and that joins to that, and that joins to that, and that joins in the background there. I don't know if that really looks like a 3D object, but it doesn't matter which way around it is. And it doesn't matter what shape that is, or a shape with straight sides. That's why I said loose-ish definition here. But if we did it with triangles, or if we had a rectangle and another rectangle, and we joined those together and went, okay, that's joined to that point, that's to that corner, that's to that corner, and that to that corner there that we can't see, there's a rectangular prism. Like this almost looks like a rectangular prism, a little bit rounded, but a box or something is a rectangular prism. And I'm looking around, a book is almost, I've got a book here somewhere, a book is almost like a rectangular prism. Okay, enough rectangular prisms. Or triangular prism. I wish I had a Toblerone. If somebody had a Toblerone to give me, then I can show you a nice triangular prism and how to eat it. Okay, so that's it. Now, to find the volume of any prism, what we want to do, and we didn't end up using this, so I'm going to delete this, is let's take that shape. So let's say that it's a rectangle. So if we've got, let's do it over here. If we've got a rectangle, and that goes along there, and our rectangle is, let's make this difference, we've got 11, 2, and this is really not to scale, is it 20? Then to find the volume of this rectangular prism, I'm just going to jump a little bit ahead to say, well, let's find the area of this face here. And so that area, the area, I'm going to call it of the base, and we're going to multiply that by the height. So that base is repeated on the other side, and the height is 20, so we're going to times it by the height. Now it starts looking in the next line, equals area of base. Well, how do we work out the area of the base? Well, area of a rectangle's just length times breadth, right? 2 times 11. And then we need to multiply it by the height, so we need to multiply it by 20. Now this might look like, volume is length times breadth times width or times height or something like that. And I purposely don't want to think about it in those terms. I want you to think about it as, take the area of this base and then just multiply it by the height. And we get, whatever we get, 22,440 units cubed. Because I don't know what units these are. And the reason for thinking about it in that is to go, well, let's say we had a triangle here. And we had a triangle, and there's our triangular prism. There's, almost looks like a little tent. And so there's our tent. And we've got a base here of, let's make this one 10. Let's make the height. I'm going to do that in a different color here. To go, the height here is maybe 4. And the length is, or this height I should say, is, well, that looks like it's 20 as well, maybe. So now we're going to use the same formula. So it's not, oh, here's a brand new, now it's a triangular prism, life changes. No, volume is area of base times height. Now I'm using capital letters here because this base is the triangle and this height is this big height, not this little height. So area of base, well, this base in this case is the base in this case. So it's something terrible, right? So the base in this case is a triangle. So this triangle here, we want to work out its area. How do we work out the area of a triangle again? Oh yeah, it's half base. Now this gets confusing because their base is all over the show. But just looking at that triangle, half the base, so the base is 10, times the height, the perpendicular height, which is 4. Okay, so that's for that. And then we want to still multiply that by the height of the prism, so the big height, hence capital height, of 20. And we can get our answer, whatever it turns out to be, probably about 400 or so. 400 units cubed. Let's check. 520, 400 units cubed. So cubic units, so it might be centimeters cubed. But it's that same formula. Area of base times height. That's the concept that we want. So if the example here in our notes, which I'm just going to brush through quickly, is if we were given a shape, I don't know what shape this is, 1, 2, 3, 4, 5, 6, so it's a hexagon of some kind, and that hexagon's exactly the same on the other side. And this area of this hexagon is 10 centimeters squared, and this height is 3 centimeters. Well, it's easy to work out volume. It's not, oh, well, what's the volume of the surface? No, area of base times height. So the area of this is 10, the height is 3, 30 cubic centimeters. Okay, so if we took a cylinder, so let's say we've got a cylinder. Here we go. And this cylinder could be anything. But let's just say, for argument's sake, it was like a tin of baked beans. I'm holding off eating these beans so we can keep using this in our examples. And we said this height is 10 centimeters. And the radius, now the radius is 4, so I want to use 4 centimeters. And we say, how do we work out the volume of this? Well, although it's not technically, or it's not a prism, it kind of looks the same in that instead of having a rectangle or a triangle on the bottom, it's just got a circle. So it's like we take the circle. I'm just realizing that I keep doing this. There's what I was probably covering up earlier. I keep on forgetting this. This here, we had the area of the base, and it was behind me earlier, wasn't it? Okay, hopefully it's there, but the concept was the area of the base times the height. So it happened to be a triangle and the height. Okay, just sorry for moving backwards like that. So the area of the base times the height, and there it is. Okay, so the volume, let's say that the base is a circle, the same concept. It's the base times the height. So in this case, it's still area of base times height. Our area, well, our base is a circle. How do we work out the area of a circle? Well, pi r squared. Well, r is 4 in this case. What's the height? 10. What's pi times 4 squared times 10? Calculator. Pi 4 squared times 10. 160 pi. We hit the S to D button so we can turn it into a decimal. 502,65 centimeters cubed. So there it is. But our key, this is our key. Area of base times height. I just want to take over that too. So then it can apply to any prism or cylinder. Okay. Apart from covering this up, earlier. Hopefully that's somewhat helpful.